Hello students, welcome to the video. So in the last lecture we learned about LHL, RHL and limit. So I will repeat one more time what LHL, RHL is. So LHL is left hand limit. That means if we want to find limit at A, if we approach from the left hand side, then this limit is called left hand limit. This is called left hand limit. And what is RHL? This is A, and we want to approach A from the right hand side, so this is called RHL. Okay, how we write it? Limit x tends to A minus f of x. This is LHL. And what is RHL? Limit x tends to A plus f of x. Limit h tends to 0 f A minus h, and this is limit h tends to 0 f A plus h. Okay, now if LHL and RHL exist and equal, then what we say? Limit exist and it will equal to LHL and RHL. Okay, how we write it? Limit x tends to A, fx will be equal to L if limit x tends to A minus fx equal to the limit x tends to A plus fx equal to the L. यदि इसकी लिमिट L है, इसकी लिमिट L है, तो इसकी भी लिमिट L होगी और दोनों की एग्जिस्ट करनी चाहिए। अब हमने कुछ कल एग्जांपल्स देखे थे जिनमें हमने लिमिट निकालने की कोशिश की थी। अब आज हम कुछ ऐसे एग्जांपल्स देखेंगे जिनमें लिमिट एग्जिस्ट नहीं कर रही है, ठीक है, और लिमिट की प्रॉपर्टीज देखेंगे कि लिमिट की क्या क्या प्रॉपर्टीज होती हैं। अब हम लिमिट निकालने की कोशिश करेंगे पॉलिनोमियल्स की, ठीक है। तो पॉलिनोमियल्स कैसे होते हैं वो देख लेते हैं पहले। पी एक्स इक्वल टू ए एन एक्स की पावर एन प्लस ए एन माइनस वन एक्स की पावर एन माइनस वन प्लस ऐसे ही चलता जाएगा ए वन एक्स प्लस ए जीरो, एंड दीज ए एन माइनस वन ए वन ए नॉट ये कहाँ बिलोंग करेंगे? आर के अंदर। नाउ आई वांट टू फाइंड दैट द लिमिट ऑफ दिस एग्जिस्ट और नॉट at any point A. Okay, so I want to find limit x tends to A px. What is this limit? So what I need to find? LHL and RHL also. Okay, so I want to find first LHL. So first of all we will found LHL. Okay, what is LHL? Limit x tends to A minus f of x. Okay, this will be equal to limit h tends to 0 f of A minus h. So here f is b. Okay, so I have to put A minus h in this instead of x. Okay, so an a minus h to the power n plus an minus 1 a minus h to the power n minus 1, and limit is 0 going to 0. A1 a minus h plus a0. Okay, I just put a minus h instead of x. Okay, now there is no denominator here. You can see there is no denominator. Okay, so there is no chance going to infinity. So what I can do, I can put directly h equal to 0 in this. Okay, so what will what it look like after that? An, a to the power n plus an minus 1, a to the power n minus 1, dot dot a1 a plus a0. So this will be the LHL. Similarly, RHL will be same. Okay, so LHL and RHL are same, or this will be equal to the limit x tends to a px. So what we can say here, so limit of a polynomial always exists. So now we'll see some examples in that limit does not exist. Okay, so here there is an example, here is an example. So these type of functions are called piecewise functions. Okay, what these functions do, these functions change their definition at a certain point. Okay, so the definition when x is less than 2 is this, x plus 1, and definition x is greater than 2, 4x is greater than 2 is x square minus 4. So it is changing its definition at a certain point. So these type of function are called piecewise functions. So now if x is less than 2, this is a polynomial x plus 1. As you can see, this is the type of a a1 x plus a0. Here a1 is 1 and a0 is also 1, and all the other an type an are zeros. Okay, so this is a polynomial and this is also a polynomial x square minus 4. So these two doesn't have any problem in their domain. Domain means for x is less than 2 and x is greater than equal to 2. These doesn't have any problem now, but there is a problem for this function. Where is the problem? At this point. We have to find the limit at this point because it is changing its definition at this point. So we'll find LHL and RHL. Okay, so first of all LHL निकालते हैं. Limit h tends to 0 f. What is the a? A is 2. Okay, so 2 plus, sorry, 2 minus h. Now if यदि मैं दो में से कुछ पॉजिटिव नंबर घटा देता हूं तो वो दो से छोटा हो गया. ठीक है, स्ट्रिक्टली छोटा हो गया. तो यहाँ पे कौन सी डेफिनेशन काम में आएगी? एफ एक्स की ऊपर वाली, x plus 1 वाली, because for x is less than 2 this is the definition for of fx. Okay, so I'll put 2 minus h in the place of x in x plus 1. Okay, so this will be equal to limit h tends to 0, 2 minus h plus 1. This will be limit h tends to 0, 3 minus h, and this will be 3 when h goes to 0. Now RHL, limit h tends to 0, f2 plus h. Now I added h, a small quantity, in 2, so it will be greater than 2, and for greater than 2 what is the definition? The definition is x square minus 4. So I'll put 2 plus h in this. Okay, so what it will be? Limit h tends to 0, 2 plus h square minus 4, limit h tends to 0, 4 plus 4h plus h square minus 4, and it will be limit h tends to 0, 4h plus h square, it will be equal to 0 as I put h equal to 0 here. So as you can see here, LHL is not equal to RHL. LHL is 3 and RHL is 0. So LHL is not equal to RHL. Okay, so limit will not exist here. Okay, now we'll do in a different method which I talk about in the last lecture in the end. So what was that method? The method was, if I goes from the left hand side to 2, so I will start from 1.9, then 1.99, then 1.9999. So here I am going towards 2. Okay, as 9 goes to 9999, so I'll goes to 2. Okay, so values of functions at 1.9 is this, at 1.99 is this. So here you can see that we are going towards 3, and we have also got 3 from here, from LHL part. Okay, now from the right hand side, I'll start from 2.1, then 2.01. So what we are doing, so here is 2, here is 2.1, here is 2, here is 2.01, here is 2.001, here is 2.0001. So we are going towards 2 from the right hand side. As we goes towards 2, so you can see that we are going towards 0 from the function side. As you can, there is a small quantity which is going towards 0. Okay, here we saw from two methods that we are not getting limit because LHL is not equal to RHL. Now we'll look at the graph of this function. So what is this graph? So here we can see that for x is less than 2, here is 2, this is 2, this is 1. So for x is less than 2, this is x plus 1's graph. Okay, and for greater than equal to 2, this is x square minus 4. Okay, so here you can see that if from left hand side I am getting 3, this is 1, this is 2, and this is 3. So from left hand side I am getting 3, and from right hand side I am getting 0. Okay, this is 0. So from left hand side I am getting 3, and from right hand side I am getting 0. So as you can see, the graph breaks here because limit does not exist. Okay, if left hand side and right hand side were equal, so these graph will be at the same point and the graph will not be broken here. Okay, so from the graph you can see also, if the graph is breaking, then you can totally say that limit does not exist. Okay, now we'll forward from the for the properties of the limits. What are these properties? First, if I have given two functions fx plus gx and I have to find the limit at a same point, so what I will do, I will distribute them for fx tends to a fx and x tends to gx, and here I'll consider limit x tends to a, fx is L, and limit x tends to a, gx is m. So what I'll write, I write L plus m. Okay, if fx minus gx, then I'll put minus here. Okay, and L minus m I'll get. If I multiply a constant number c, so I can put c outside and find limit at x of fx. Okay, so fx is L, so this will be c into L. And if I want to find limit of a product of functions, then I'll distribute the again limit individual limits and multiply them. Okay, and for dividation also I will find individual limits and divide them. But here m will not be equal to m, oh 0, because if m is 0, then this L upon m will not be defined because it will goes to infinity. Okay, and if I want to find x tends to a fx to the power n, what will I do, I'll just limit will be inside and I'll power n. Okay, so this will be L to the power n. And similarly for uh, limit x tends to a, fx to the power 1 upon n. uh, these two things are same. Okay, so I'll again put the limit inside, and this is l, so l to the power 1 upon n. So we'll try to find limit of this function here. So first of all, we can see that these two are polynomials. Okay, so these two limits exist individually. So first of all, we will try to find these limits of these functions. So I'll consider fx equal to 2x square minus 3x plus 1, and I'll try to find limit x tends to 2 fx, and what it will be, I just put 2 in the place of x. So 2 square minus 3 into 2 plus 1. As you saw here, you can see I want to find the limit at a, so I just put a instead of x. This was our LHL. So what I'll do here, I'll just put x equal to 2 and find the value. 2 into 4, 2 square equal to 4 minus 6 plus 1, this will be 8 minus 6 plus 1 equal to 3. And now I'll consider gx is x cube plus 3, x cube plus 4. So limit x tends to 2 gx, so it will be 2 cube plus 4, so 8 plus 4, this will be 12. Now as you can see that I can give them L and M. Okay, so here M is not equal to 0, as you can see. So I can use this quotient law of limit. So this will be L by M. So what is the limit of x tends to 2 fx upon gx? This will be L upon M. What L is 3 and M is 12. So thank you so much for watching. Please like, share and subscribe.